Okay, but now we want to look at the data. It's very important that you look at the actual data before you leave a job site, just in case something went wrong. You don't want to have to drive all the way back to repeat the test. Um, what do I mean by what could go wrong? Well, let me purposely do a bad test to show you what that looks like. So I'm arming the sensor, it's turned orange. I'm gripping it firmly like I'm not supposed to do, and I'm going to drop it crooked. And so it's doing its calculations, red, green, red, green, red, green. And now it's turned solid green. Okay, so that that indicates that it was a good drop. I tried to do it crooked, but I didn't do it crooked enough. So let's try that again. Arm the sensor. I'm going to hold it really crooked this time. I'm going to let go. It's doing its calculations. Red, green, red, green. And now hopefully it'll be blinking. Ah, there we go. So it's blinking green. That means it was a safe fall distance, but it's not accurate because it landed too crooked to get a good result. So that's what the blinking light indicates, is that you should repeat that test. Okay, so now let's look at the data. I'm going to share my screen so that you can see how that's done. So we have this app called the FreeFall app, and this is what it looks like. And we have this USB cable. One end plugs into the computer, and the other end plugs into the ball. You want to have your FreeFall app running before you plug it in. That's what works the best. And you also want to have your FreeFall sensor on when you plug it in. It's on, I'm plugging it in, and it's complaining about there's no files in this folder. That's okay, because I haven't saved any for this one yet. Okay, so it automatically brings up the most recent drop. Now this was a drop. It says it 630 inches. That's not good. That's why the light is blinking and saying, hey, it didn't register because I gripped it poorly. When I let go, it had a hard time identifying when free fall started. And so it didn't get a good fall height measurement. So that's what that blinking light indicates. If it landed too crooked to get a good measurement, the degrees would be negative. You'd have a negative degree here. But this has a 548 head injury criteria. And the max G was 149 Gs. Okay, that corresponds to the peak of this deceleration curve. And the reason why it's green and not red, even though it's not a good drop, it's blinking green because it didn't get a good fall height measurement. But it's not blinking red because the HIC is under 1,000. So if the HICs go above 1,000 or the max G force goes above 200, it's not considered a safe distance to fall onto that surface. Okay, but in this case, it was well within the limits, but it has problems. So this was kind of I purposely made this as a bad drop, but you should save your data on your laptop. Right now, the data is just it's downloaded to the laptop, but it's not saved in the laptop. And you don't want to just leave them in the FreeFall device because if your battery goes completely dead, you might lose some data. So you want to save all the important data on the laptop. So I'm going to show you how you do that. You press the save button, and it's going to ask you for a description. So this was a crooked hand drop with bad release. Okay, that's why it was a bad release. That's why the fall height was drastically wrong. Okay, and I'm going to say, okay, now when I say okay, it puts the comment down here at the bottom of the graph, and it wants to save the file it chose its own file name. Now, this file name is based on the date and time of the drop test. The FreeFall device has a calendar app, keeps track of the date and time. but it gets the date and time from your laptop. So these drop sensors are manufactured in Mountain Time Zone. And you probably, if you live in a different time zone, you don't want to use Mountain Time Zone. So one of the first things you want to do is plug it into your laptop so that it can get the correct date and time for your time zone. And if when daylight savings time changes, you'll want to do it again just to get it the right time onto your device. Or if you travel to another time zone and your laptop automatically updates, you'll want to plug it into your FreeFall, so it has the current date and time. Okay, and you'll want to pick a folder that you can remember. I'm going to put mine under my name here under the drop Delphi, and this is serial number 226. So I'm going to make a folder, serial number 226. And I'm going to open it. I'll open that new folder that I just made, and I'm going to save it. Okay, where did my save button go? No, open, I guess. Okay, yeah. Now I'm going to save it. Okay. So that was a crooked hand drop. Oh, I should have said hand drop. Okay, so that's okay. We can fix it. I'm going to click this button, edit the comment, and I'm going to say crooked hand drop with bad release. And it's going to complain when I try to save it. It says, oh, it's already exists. You want to overwrite it? Yes, I'm going to overwrite it just to make sure you don't accidentally overwrite something that you didn't want to. All right. Now, so that's drop number 9. I want to get the other drops that I did in this video. So that's drop number 8. Yeah, you select which one you want. You push this lightning bolt and it downloads the data. But again, if you want to keep it, you got to save it. Okay, so now this was not a crooked. I tried to do it crooked, but I didn't do it crooked enough. So I'm going to take out the crooked. Hand drop. Okay, so this is going to be so this was about 32 inches. I didn't measure it with a tape measure, so I don't know exactly, but I'm just going to go by what it says here. 32-inch hand drop, and it was a bad release. Okay, so I'll leave that in there. All right. Notice it put the comment down there. It saves it, and it puts it in the same folder. And by the way, the next time you plug it in, it'll remember which folder you used. So that's nice. All right, so we got drop 8 and drop 9, and now I want to get drop 6. Now, the 7, this was the one that I did where I did it correctly. I was holding it by the fingertips, and I had my arm fully extended. So I'm going to get that one. And that one happened to be a 26-inch drop. Okay. It landed with 3 degrees. And it had a head injury criteria of 282 and a max G of 109. This max G correlates to the peak of the deceleration curve. Okay. So I'm going to save that one. That one's a good drop. So this is and I didn't measure it with a tape measure. So I'm just going to have to go by what it says here. 26-inch hand drop with good release. All right, so I'm going to save that. Okay, now I've got these 3 drops saved on my computer, and I can use these arrows to scroll through the data quickly. You push the right arrow to go forward in time, the left arrow to go back in time. And it figures out the order based on the date and time that I chose for the file name. This is why I suggest that you keep the date and file when you go to save it. Use the file name that it chose. You can add to it if you want. If you want to, if you want to save it and put some description on there, or whatever you want, you can do that. But I suggest you leave the date and time at the beginning. That way, your data is in chronological order. So now we have 4 drops. One of them is a duplicate. So drop number 7, there's 2 of them. And I spelled description wrong, but anyway. So I'm just going to delete that. That's what the red X does. This does not delete them from the drop sensor. It deletes it from your computer. So that one's gone. If you want to erase the drops on your drop sensor, you click the erase button. This is a pencil eraser, if you can't tell. And it says, are you sure you want to erase all the drops in the sensor? You say yes or no. If you're going out to a new job site, you might want to restart the numbering. In this case, I don't want to restart it, so I'm going to say no. But if I did say yes, then the next drop would overwrite drop number 1, and it would go drop number 2, and so forth. Okay, so this is how you do a drop test. Okay, the only thing I didn't show you is measuring the height before I dropped it, but I have another video that shows you how to do that. Okay, so now I want to show you some more data here. Okay, so the way the drop sensor works is it measures 3 different axes. It measures the x-axis, the y-axis, and the z-axis, which is the vertical axis. And it uses the Pythagorean theorem to combine all 3 of those accelerometer data to make one impact curve. And so using the Pythagorean theorem says that you take the square root of x squared plus y squared plus z squared, and that gives you the impact curve. All right, so, but what I want to show you here is the z-axis. That's the vertical axis. Now, the vertical axis has actually 2 accelerometers. It has the main accelerometer that can go up to over 200 Gs to measure the maximum impact force, but it also has a low G Z sensor for the Z-axis, and that's what this data looks like here. So let me explain. This is a little bit complicated, but it's not too bad. Okay, so this is while I'm holding the drop center before I let go, and it's sitting here near 1 G of acceleration because we defined Earth gravity to be 1 G. And then I let go of the drop sensor, and it transitions from 1 G down to 0 G. Now it's in free fall. And while it's in the free fall, we do an auto calibration, and then it measures the impact. Now, since this is the low Z accelerometer, it doesn't go measure the full impact. This one saturates here at 3 G in this case. It doesn't go up to the 200, but the high accelerometer for the z-axis does. But this is what's used to calculate the fall height. Now let me explain it. Now, so this is the actual data. Now these 3 points here are artificial. They're not actual what the sensor measured. They're put in there as markers. This first marker indicates, okay, this is where we've detected that we're beginning into free fall. We're starting to fall. And what it does is it calculates the time from the initiation of free fall to the impact, and it uses that time to calculate the fall height. All right. Now these 2 indicate the beginning of the auto calibration. One of the things, our drop sensor is the most accurate sensor on the market. It's 4 times more accurate and precise than anybody else. And one of the things that makes it that accurate is and we have this patented, that it doesn't, every time you do a drop, it does an auto calibration to keep the sensor on track. And so these 2 markers indicate this is the beginning of the auto calibration, this is the end of the auto calibration, and then you have the impact. Okay, so that's a hand drop. Let me show you the other drop. So that was a good drop with a good release, and that's the one I showed you. Now this is this is the attenuation curve, the deceleration curve. Now this is the one that I had a bad release. So the first one I was holding it by my fingertips. This one I was firmly gripping it, and you'll notice that it takes a longer time to go from 1 G down to 0 G. That's because I'm not a robot and I can't let go as fast as a robot could. And so human error, it's going to cause a longer delay, and that's going to affect the measured fall height. So this was with a bad release. If we go back to the other one, this was fingertip. It's a little better, and there's not a huge difference, but it does show up in the fall height calculation. Okay, so that was a bad release, but it actually wasn't as bad as it could have been. So this is the one that was a really crooked and a bad release. In this case, I did such a bad job. It was tipped so much that it wasn't even measuring 1G. It was a half a G because I had the thing tipped, and so the Z-axis wasn't feeling the full gravity effect of the Earth, and so it didn't detect free fall, the beginning of free fall. It detected the impact, but because it didn't detect the beginning of free fall, the fall height measurement is completely wrong. So just to summarize, when you do your drop tests, make sure you try and hold it parallel to the ground. You hold it with your fingertips before you release it, and you don't do your arm horizontal or at an angle. You got to stand up and extend your arm so that you get a better drops. And that's how you get the best results from a hand drop. And I'm going to make another video to show you how to get even better results than that. So watch the next video.